Hello again, this is Mark Summers from Summers Technical Services. We're going to continue on with our video on this duct flow using SOLIDWORKS flow simulation. So the previous video we talked about fan curves and things, and so now we're going to use that data to try to run an analysis. So here's my manufacturing model. It's got the Comair Rotron fan we talked about. Here's my 4:1 or 1:4 duct, and these straight duct tubes that go over the radial heat sinks. And maybe to make it a little bit more clear, let's turn on this exploded view and kind of take a look at what's inside this thing. Let's see if we're going to animate this thing. Yeah, here we go. So we'll animate this thing and kind of see how it goes together. So these split tubes wrap around each one of these individual heat sinks, and it's got some caps on each end that hold that tube in place. And so this is what we're cooling. We're trying to get the air flowing over these heat sinks and or heat pipes to extract the heat. There's a big hot plate that mounts to the front face of all of these heat sinks, and we're trying to get the heat out of there. And we're going to use a combination of conduction through the heat sinks and phase change through those heat pipes, and also convection, forced convection, to get the heat out of the heat sinks and into the air and out away from the hot plate. Alright, so maybe we'll stop that. So again, this is the manufacturing model. Let's take a look. Maybe another thing we could do here for grins, we can go back to the model, grab this front plane. We'll just take a section cut through this thing, kind of walk our way through. You can see what the geometry is doing through the fan. So here's the entrance from the fan into the duct. It divides the flow into two annular rings, for reasons we'll see here in a minute. And it wraps around, and that divider gets wider, and it's got a little bullet there in the middle that transitions that those subdivided annular rings into four different sections. And it floats around and it morphs itself into a shape that eventually changes and looks just like the end of the heat sink. And so that transition right there, all of the air is flowing right into those two voids on either side of that heat sink. And then those heat sinks just continue on with that constant cross section. And there's different lengths of heat sinks and different configurations of those heat pipes, and we'll deal with those later. Alright, so this is way more complicated than I need for my flow simulation, so I made another configuration that just has the basic details that I need to do my simulation. I don't want my meshing to be so difficult, and so I simplify everything. The geometry is the same. What I do on the duct model is I've had trouble, sometimes I run into trouble with using these SOLIDWORKS models, especially when they have a lot of swoopy, lofting, sweeping surfaces. It gets confused sometimes. So what I did was I'll export the SOLIDWORKS model as a step file and then bring it back in. So this is a step version of the geometry that you saw earlier. And then I simplify the fan just to have a couple of pieces. This middle piece here is the represents where the air is coming through, and then the inside outside parts just capture that airflow. And so we'll use that when we do our flow simulation to define those fan curves we talked about in the previous video. And then these plugs are in here not because I want to plug these holes, but because I want to be able to ask for volumetric flow rates coming out of this into this duct, and so I use these little plugs to allow me to do that. We'll turn those off before we run the analysis so that the air can come out, but you'll see later when we do our goals what that means. Alright, so before you start running this thing, you'll need to make sure you go check to make sure you've got your flow simulation add-in turned on, and you do that through Tools and then scroll down here somewhere and find add-ins. And you want to turn on the checkbox for your add-in for SOLIDWORKS flow simulation right here. So that checkbox there, turn that on to turn it on, and then turn this checkbox on to start it up. Every time you start SOLIDWORKS, it'll load if you have that one checked. So I've already got mine loaded, and I see the tab here, and so these are all my buttons. And so I think I'm ready to rock and roll with my flow simulation. And so let's come up here to Flow Simulation tab, and I always start with the wizard. The wizard walks me through all the settings, and it's really pretty handy. And so let's see if the wizard can walk us through this thing. So the first thing we're going to do is define a project name, so maybe I'll call it STS-801, and we'll go next. And it's using the current configuration, which is what I want. And it's asking me for my default units. I can change these at any time, but I'll generally want to use inch, pound, second because all the models are in inches. And maybe I decide that the temperature I want to change to Celsius because that's what the data sheet for my PeltA devices eventually is. And so I can change any of these individually. And when I start doing thermal analysis, I'll want to change my heat loads. I want to get away from this BTU stuff. I want to go to joules and watts. We're not going to do any heat conduction now, but in the future I'd want to change those. So anyway, you can customize these however you like. Once you get them like you want, you can go next. And here's where we decide what kind of flow we want. So the picture over on the left is perfect. The top picture is external flow. The bottom picture is internal flow. And we want to do external flow because there's going to be air on the outside here, ambient air flowing into our duct, and it's going to be expelling out this end. And so we want internal flow. Whoops, what happened to my window? There we go. So I want external flow, and I'm not going to do heat conduction. I'm not going to do radiation. Time dependent. No, I want to do just steady state. Gravity, I could turn gravity on, but since we're blowing air through this thing, I think gravity is going to have very small impact, so I'll leave that off for now. Rotation free, sir. I'll leave all these blank for now. And I can run it later, and I can turn on gravity, see if it makes a difference, if I'm worried about that. So we'll say next, and it's asking for our default gases we're going to use, and we're blowing air through this thing, so I'm going to double-click on air, and it shoots down the default fluid as air. And it's asking me, do I want laminar, turbulent, some combination? I'll just leave it on both. It will change the equations used to solve the flow based on the flow rates, and so I'll just let SOLIDWORKS take care of that. I don't have high Mach number here, and I don't worry about humidity, and so I'll go next. And surface roughness, if I'm worried about friction factors and pressure drops due to roughness of the duct, I might turn that on and give it a roughness value, but for now I'll leave it as 0, and then I can run it again later if I feel like I want to check to make sure that's not negatively impacting my design. And the last tab here, it gives me a chance to define the thermodynamic parameters of the ambient air, and so I'm going to assume it's 1 atmospheric pressure, and then maybe the room temperature is 70 degrees Fahrenheit, but I've got my Celsius turned on, so I can type in 70F and then hit enter, and it'll convert it to Celsius. So it really does a good job taking care of the units for you. I can have airflow, free stream airflow if I wanted, but I'm going to have the fan blowing the air, so I'm not worried about that. And here's some other parameters that I may or may not understand what they mean, so I'll just leave those as default and say finish. And then what happens? There we go. All right, so I've set up my flow simulation. I thought finish. There we go. Okay, so what it does, it creates a new tab here on my manager for me. So I have a tab, I have a feature manager for my model, and I have a configuration manager, and now I have a flow simulation manager. I got a different tree over here, and so I can toggle between these things to see different aspects of my model. And all these things all live in this one same model still. So while that thing is thinking, I'll pull the spreadsheet over. I created this spreadsheet based on the data sheet we talked about last video with the flow rate versus back pressure. And it just converts that curve data from the data sheet into numerical data I can actually input into flow simulation. And then down here, I just converted the CFM in inches of water over to cubic meters per second in pascals. So it's the same data, different units. And so these are the two curves that match what the PDF file we looked at yesterday. So I'll use those numbers to input the fan curve into SOLIDWORKS flow simulation whenever it comes back to life here. Be patient, Mark, be patient. All right, so here we're back to life. So what it does, it creates this computational domain, and this is way too big for me. I don't really care what the velocities and pressures are over here because I know they're going to be virtually unchanged. So I need to make this smaller, and so I'm going to select the computational domain, and I'll look at this thing at a front view. And I will select computational domain. I want to pull these in. So the idea is you want to have about as much room. You want to pretty much a part width on each side before you get to the wall there, so I don't get any boundary wall errors in my analysis. And so this thing ever comes back, I'll drag this thing in. And, you know, that looks pretty good there. So that's about 12 inches, it says. And I'll do the same thing over here. And so that looks reasonable. And so what I can do is I can type these numbers in instead of dragging this stuff around. I want to right-click on Computational Domain, hit Edit Definition. And I want to change these numbers to nice even numbers. I'll make that 12. I'll make that minus 12. And then for Y, I want to have that as minus 12. And plus Y is 12. And then maybe I'll spin it around and see what it looks like in the other direction. Need to squeeze that down as well. So if I select this thing and wait long enough time, why is this thing taking so long? There we go. So I'll squeeze this down this way. Squeeze this one back this way. I want to give myself some room so the air can gradually make its way in. So maybe that's a little too close. Maybe I'll get it. Maybe I'll make it about minus 12 and maybe 16 or so. Right click, edit definition. Now I'm looking in the Z direction, which is down here. So I'll make this 16 maybe, and make that minus 8. And so I don't know, that looks reasonable. Maybe I'll make that minus 12. So that seems more than enough room to settle things out. So I'll agree with that. And now I've got my computational domain set. So I'm going to save this thing as I go in case something crashes. And all of this stuff, all the model stuff, all the exploded view stuff, it all lives in this one model. It's one assembly model, so it's really pretty handy. All right, so let's go to component control and turn off these little plugs here because I want the air to be able to blow through those things. And so I'm going to come up here to tools, and a lot of these commands live inside this thing here. So tools, flow simulation, I'll go to component control, and I'll come over here and I'll find those little caps, and I'm going to turn those off so that it doesn't use that CAD data to plug those holes. Component control 1, 2, 3, 4. I guess that's all of them. And you can see, I'm not sure, did I really turn them off? Tools, flow simulation, component control. There it is. That's the duct. That's the fan. I've turned off those 4. All right, I guess they're in pairs, I guess. Okay, so those are turned off as far as the flow analysis show. I can still see them, but they're not going to use it in the analysis. All right, the next thing I need to do is define my fan curves. And so I'm going to come over here and temporarily turn off my duct so I can see both sides of the fan. And again, I'm going to go Tools, Flow Simulation, And I'm going to say insert, and I'm going to go insert a fan. And I want to choose, I can have an external inlet or outlet fan. That would be air that's coming outside of the computational domain. This is all embedded inside, so I want to do an internal fan. And I just answer the questions. Faces fluid exits the fan is right there. Faces that fluid enters the fan is over here. This thing will spin around. Be patient. Fluid enters the fan over here. And so there's a goes into and the goes out. And I've already predefined this axial fan. I've already defined it in my user definition. So you'll have to type those numbers in from that spreadsheet. And I'll show you what that looks like if I come down here and hit this create edit button. That's what you're going to do. And so here is all the information for that fan I created. And here's those curves based on the data over here. And you can see these numbers down here. Here are these numbers right here. So I just typed in that data under tables and curves. And the software will figure out where I am on that curve and compute the flow rate that I'm getting out of my fan, which will be something less than 235 cubic feet per minute because of the back pressure. All right, so I've defined the fan. I've told it which way the air goes in and the air goes out. So I'll say OK. And again, I start getting things in my flow simulation tree over here. So now I have that internal fan defined. All right, so let's go back to the model. Just turn this duct back on. Just temporarily hit it a minute ago. All right, now what do we need to do? The last thing I need to do before I run this thing is do some goals. And the goals are a way you tell SolidWorks, hey, when you get through running this thing, I want answers to these questions. And so I want to know the answer to a question. I want to know how much air is coming out, what the volumetric airflow out of these end is. And I want to also know what's going in, because what goes in should equal what goes out. And it's another way to check my analysis to make sure it's correct. So I'm going to come over here to goals and right click on goals and say insert surface goal. This is something that's happening on a surface. And so I want to start over here on the fan side, and I want to know what the flow rate is going into this fan. So I want to select that face. Goes in the blue box, and I can ask for freaking anything I want. It gives me all kinds of options, but I want the volumetric flow rate, and maybe that's all I want. Velocity I don't care about. I can get that other way, so maybe that's all I want. And that just adds that goal to the list. Now let's do the same thing over here. I want to know the volumetric flow rate at each one of these guys. So I'm going to right click, insert global goals, insert surface goals. And I'm going to do 4 separate ones. I'm going to do this pair right here first. Control click the second one. So those 2 faces are on there. I want volumetric flow rate. Boom. And you can see it just adds them to the list here. And so now I want to go over here, this guy, control click that guy, and again, right click, insert surface goals. I pre-selected them, there they are. This will be volumetric flow rate again. And so I got those 2. Let's do these third pair. Right click, insert surface goals. And there they are, volumetric flow rate. And this is taking a long time, but I'll do the last pair here. And right click and say insert surface goals. And the last pair, I'll also ask for volumetric flow rate. All right, and as I'm thinking about it, that volumetric flow rate is going to show up in cubic meters per second, which I don't like. So I can go back here to input data, right click on input data, go to units, and I can change my volume flow rate. Where is flow rate in here? Where is my flow rate? Velocity, where is that going to be? Volume, I want cubic feet. And somewhere in here it's going to ask for, it's going to define volumetric flow rate. And I don't see it. So maybe I'll give up. Somewhere in there you can set volumetric flow rate. And you can change those anytime you want, even after you run the analysis. All right, so now I need to do mesh. And so I'm going to right click on mesh and do a global mesh, and we can have multiple day-long videos about how to do different kinds of mesh. It's probably the most important thing to do to get accurate results, and it's probably it is the most complicated thing to work through, so we'll have to do that in another video. I can do a global mesh setting by just running this slider back and forth. 3 is default, 4 is finer, finer, finer. I go all the way to 7. And I'm just going to leave it at 3 to start with a global, pretty medium-based mesh, and define it later. I want to show it here. Refine it later in areas I'd really worry about, and so I can do some refined mesh. But we'll run it the first time, just make sure that everything's running correctly. So once you get that done, then all you do, I want to save this thing just to make sure in case something fails. Now we're going to hit run. And we're always going to want to solve new calculation. I can run this thing. If I had my neighbor's computer over here that was available, I could run this thing on somebody else's computer. And I can also, once this thing launches, I can let it run in the background and go back and do other SolidWorks work. It leaves my SolidWorks license available. So we're going to run this thing, and then we're going to sign off for now and come back and look at the results and talk about how to do those results and interpret the results once the thing is run. So stay tuned for the next video from Summers Technical Services.